All right. Hello, it's Andrew here. Hello, it's Andrew here. This is my one-dimensional Richards equation model from the GitHub repository, and this was written just to demonstrate how you can a very simple Richards equation using Python. To quickly run through it, it should all run. There was an error with the legend here, so you sometimes the Python commands get updated slightly, so you might just have to replace that line with a simple legend statement. Anyway, this model is running, and it's simply running for a steady state infiltration scenario from hydrostatic conditions to initially here to a final steady state infiltration profile where the pressure and water content become uniform in a vertical column. Okay, now that's nice to demonstrate things, but if you want to use this in a practical sense, you want to look at time series of boundary conditions. In particular, you might want to look at a time series of infiltration at the top. So I'm going to quickly show you in this video how you might do that, and you're going to have to modify the the function called Richards model. So here's the function Richards model, which is the Richards equation solver. And in particular, we're interested in this upper boundary condition, which is determined by these lines here. Currently, we have this variable qtop coming in, which can be empty, and if it's empty, then we actually apply this boundary condition, which is a fixed pressure head boundary condition, where the pressure head is given in this variable psi top. And if qtop is not empty, then we simply impose qtop as the flux on the uppermost boundary of the model. So what we want to do is we want to actually make qtop a function of time. Let's quickly try to do that. Now first of all, let's just come down here, and I'm going to create some arbitrary time series for qtop. So let me say that time is going to be in numpy, let's say a range from 0 to 100 with a step of 1. Let's see if that worked. Oops. Okay, 101. So there we go. So I've got my time, this is in days, 100 days. Let's now say that qt is going to be zeros len t. So qt is just 0 everywhere at the moment. What I could do is I could just make it, let's for now just do this, make it, what do I have, 0.01. Okay, so I've now got my same boundary condition as before, but I'm actually defining it as a time series. So what I want to do then is, let's see, where did I call Richards equation to solve it? I call Richards equation to solve it, sorry, here. All right. So actually what I'll do is I'll copy this entire block down here. Now instead of, okay, that should be negative, I've just noticed. Okay, so now I'm gonna somehow try and replace qtop with this time series. And what I'll do is I will also come up here and I will duplicate this block of code into a new block below it, and I'm going to call it now Richards model transient. Oops, transient. And this is going to have, I'm going to call it time boundary and qt instead. Okay. Okay. Copy that down here. This is where I was previously solving Richards equation, so it's actually going to be called Richards equation transient psi naught t blah 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 blah. Now all I want to do is instead of qtop, I've got tb, the boundary condition time, and qt. Is that clear? Yes, that's going to be fine. Okay. Just realised now I've got two different times, so in fact, let me make it simple. Let me have just one time, and that time was that time is defined by these two lines, this line here. Time grid and transient infiltration flux. Alright, so now I'm actually sending time into this function twice. First is the time grid that defines the ODE solver output, and secondly as a second separate time grid that's going to define where qt is defined. So calling it t here, but when it reads it into the function up here, it's going to have it as tb. Now, what I'll do then is I will simply, for now, comment out these blocks. And I'm going to use linear interpolation to figure out what the flux is at the current solver time step. So, how do I do that? Let's see. I want to say that Qn is something, right? Which is a function of time. It's going to be, I believe, well, I'll tell you what, because I can't remember how to do interpolation, I'm going to just try it down here quickly. Oops, what's going on here? I've got my time, I've got my qt. Okay, so what happens if I do np.interp1 t qt10? Okay, maybe it's not interp1, interp. Okay, I'm going to have to Google this quickly. Python interpolation. Is this what I want? Interp1d. Yes, I think this is what I want. Let's come down here and try it. So this is a new function. I'm going to just import this function, interp1d. I'm going to say qt fun is equal to interp1d time qt, like that. Now I believe what I can do here is I can just type in qt fun, give it any time I like, and it should return the value, okay, which it does. So if the time is 1, and if the time is 1,000, 100, sorry, 1,000, it should, yeah, okay.